The objectives for this module are to explain methods for researching and documenting the existing conditions and constraints of a site, present successful approaches to site analysis, provide examples of graphic site analyses, and provide suggestions for your senior design project. Site analysis is the process of studying the contextual forces that influence how we might situate a building, lay out and orient its spaces, shape its enclosure, and establish its relationship to the landscape. Many of the considerations discussed in this module are also relevant to infrastructure and non-building centric projects as well. Any site survey begins with the gathering of physical site data, but good site analysis goes beyond just gathering basic topography information. Let's start out by looking at a quick case study. When walking by Brown Building on campus, have you ever noticed the strange horizontal slats on the building? They aren't on all the windows in Brown Building. In fact, they appear on the west side of the building only, and specifically on windows that have no other overhang. So what are these black slats for? Take a moment and think about it, and then enter your answer in the quiz box. It turns out these slats are actually called light shelves. They're a commonly used architectural technique that helps reduce the need for artificial lighting and regulate the heat gain of the room throughout the day. The shape and spacing of the horizontal elements is actually engineered to assist with energy savings in the building, and the design team likely wouldn't have thought to include these features from just looking at a topo map of the site. They needed more information about the influence of natural phenomenon and the local area to pull this off. That is where site analysis comes in. Let's walk step by step through a typical site analysis process. The first step's always going to be drawing the site. This is best done outside of CAD. Draw the area and shape of your site, and mark setbacks, easements, and rights of way. Estimate the area and volume required for the building or other construction elements that you know about. And leave a little room around the edges to capture important items that might happen just outside the boundary of your project. You'll come back to this drawing often, and will likely end up developing several different proposed layouts as the site analysis continues, so don't get too attached to your first pass. Next, take a look at the site's slopes and soils. Analyze the ground slopes and subsoil conditions to locate the areas suitable for construction. Understanding soil structure involves knowing its shear resistance and compressive strength, its water content and permeability, and its consolidation under loading. You may find that your building needs to move slightly, or that you may need to add elements to your concept like retaining walls to accommodate the slopes and soils of the site. As you look at more elements of the site, you may want to actually use tracing paper to sketch out the key topo and soil information so that you can quickly lay different layers of information over your original site sketch as you develop your solution. Think back to your training and previous classes about the load-bearing capacities of different soil types, and don't forget to consider frost action, permeability, and drainage characteristics, as these can significantly impact your design approach. And a note of caution, while tables and public data can get you a long way, you should definitely seek input from a geotechnical engineer if you're designing anything taller than one story. Also remember that if you have slopes that are more than 5%, you should be paying close attention to the amount of soil you're going to have to move or fill to build on the site. As you reach ground slopes over 10%, if you can't avoid building on the slope, take into consideration the expense that will be involved in site preparation. Now that you've placed your building to optimize soil and slope considerations, it's time to identify water patterns at the site. Map existing drainage patterns. Site development can disrupt existing drainage patterns and create additional water flow from constructed roof areas and paved surfaces. Should you be using a subsurface or surface drainage system? Identify areas subject to excessive runoff of surface water, flooding, or erosion. Let's take a quick break here and check your understanding. Good. Okay, boundaries, slopes, soils, water, and drainage. We've checked those and feel pretty confident. Now let's look at the next layer. Check for existing trees and native plant materials. Trees affect the immediate environment. They provide shade, serve as a windbreak, shape outdoor spaces for activity and movement, attenuate sound, improve air quality, increase permeability of soil to both water and air, and prevent erosion. If we can make our design utilize existing trees and materials, we'll have a better and better looking solution. Tied to using existing trees, and to our earlier example of slats on Brown Building, make sure to evaluate solar radiation. The location, form, and orientation of a building should maintain a balance between cold periods when solar radiation is beneficial and hot periods when radiation should be avoided. How you do this will depend on the type of region you're designing for. For cool regions, you'll want to minimize building surface area, maximize absorption of solar radiation, reduce radiant, conductive, and evaporative heat loss, and provide wind protection. By contrast, for hot and arid regions, you'll want building forms that enclose spaces, You'll want to reduce solar and conductive heat gain, promote cooling by evaporation using water features in plants, and provide solar shading for windows and outdoor spaces. This sample of a single-family residence shows a good example of how a home can be designed to maximize the use of vegetation, topology, and solar energy on a site. Notice the use of overhangs to control lighting. During the heat of the day, the overhangs provide protection from the sun, but allow late afternoon and winter sunlight into the space. In addition, trees are used as a screen to block winter winds, and deciduous trees are planted to block the summer sun. These are just a few ways that you can use vegetation, topology, and the path of the sun to design an energy-efficient building. Okay, let's talk about two more things to look at before you finalize your site analysis. Remember at the beginning of this module when I suggested you leave some space around the outside of your drawing to consider external factors? One of those external factors is access and circulation paths. Depending on what type of structure or project you'll be building, have you looked at safe and convenient pedestrian access, parking spaces required, loading zones for buses, access for emergency vehicles, clear sight lines for vehicles entering public roadways, and, at least in Colorado, space for snow removal? In addition, make sure to consider where existing utilities are located. It may make sense for you to modify your design to better accommodate access to sewers, water, or other utilities. So that's it for site analysis. If you've considered the items we've covered, then you should have a strong basis for your design. Also, by considering these factors up front, you've probably reduced the cost of your project and made it a better solution all around. The question always comes up then, what are the site analysis expectations for senior design? The answer is, it depends on your project. Sorry. Observations should guide your research. Work with your faculty advisor and client to select the layers of information you need to develop a solution to your challenge that you'll be proud of. But in closing, let's review a past submission from a previous senior design team that designed a parking structure for the city of Golden. Here's their final design of a multi-story parking structure located on 14th Street in downtown Golden. To develop this final design, they looked at several factors. First, they captured the property line and gained a clear understanding of the lot and the surroundings. As a next step, they knew they wanted to maximize parking, so they placed the red box inside their project limit line to denote the maximum structure size possible on this site. They checked zoning requirements of the city, and then captured the topology. Notice, the overall slope of the site was approximately 20%. Therefore, they knew going into it that the design would be a little more costly than if they had a flat site. In addition, knowing that the site slope was steep, they wanted to look closely at drainage patterns. And those drainage patterns were specifically affected by the soil type. To recap, this team had a steep slope on their site. They looked at the drainage across the site, but then realized that that water had to flow somewhere. So they zoomed out and looked at the drainage to the existing sewer network. With this information, the team felt comfortable moving forward with their design. They didn't change the location of their parking structure. The site was too small for them to actually move it around after considering required setbacks. Using this information, they were able to create a detailed and well-developed design for the city of Golden. That's it for site analysis. Now let's check your understanding.